A man points to the sky and says, "What is that?" Mr. Gray responds, "That is the black. Don't worry, you'll never catch it." He wants Mew to know that. You can catch up to the black if you go down a black hole. Then you can catch up with something that's truly black. But when you stare out into space and you see that blackness on the edge, you can't catch up with it. But with a black hole you can. And have it catch up with you. If I look down a black hole, I guess I'd see black still. But if I turned around, I'd just see the universe as it's falling into it, with black for everything not in the black hole, off in the horizon. But I'd also see that from within the universe. But maybe if we caught up with the black at the edge of the universe, then we'd reach the event horizon of a black hole. And each black hole we see is another singularity within our larger black hole that hasn't coalesced with another singularity yet, or uncoalesced singularities. Would make you think you lived in a singular universe and it was filled with black holes. Maybe we're just very early on in our journey down to the center of the black hole, where time stops and rebounds. So you reach the center, and then time reverses, and then marches forward in the opposite direction, Philip? What are you saying? I'm saying it's a beautiful idea, but it marches forward in a particular direction. This is the bottom of the singularity. The light is flipped in reverse time. If it spews charged particles, spews particles that have a spin that's two possibilities, and maybe these two particles have opposite spin. So maybe the center of the singularity eviscerates everything to the point where it produces particles that have some achirality. And that achirality is either spin up or spin down. Just guessing. So what happens is you loop around the singularity. Thus the beginning of the universe looks like the spewing of particles. It's like the answer at the bottom of the singularity for those particular occurrences, those particular particles. Our singularity, the one we live in, happened to have the properties of a few different universes, as the property of its parent would have many universes. Thus, if it didn't interact with any singularities within itself, it would still have the combination of many universes worth of rules, since those rules dictated the universe in which it inhabits. Now, the question is, what type of particles exist in a parent universe when a child universe has some particular set of particles? How does the Hawking radiation change as we jump up? I suspect our parent universe has more kinds of particles than we have. And eventually at the top there's a universe with absolutely no life, but whose black holes manage to be the combination of properties that allowed for life to develop. Once you get to the point where life can develop, what can you say about the inside of the black hole? Lifeless is what it looks like. Lifeless from our perspective. But if that black hole only exists in one universe. But the way in which reality may interpret the scattering of energy going down a black hole may be different depending on who the observer is. Part of that splayed information in this black hole, from the perspective of the outside, is reality to me here in the black hole. But it looks like things are totally torn apart on their way down a black hole. But torn apart to what? Torn apart to the point at which they're flung back with something newly created, an aspect that resulted from the tearing and gave an inverse, or some newly generated inverse based on resonance between inverses as they fall down a black hole and the particle that initially entered the black hole. So this universe looks like the set of things that point from something on an interior to something on the exterior, and then something from the interior to something of the exterior of a black hole. So the inside of another universe points to two black holes, and these separate black hole universes in the first universe both point to two separate sets of black holes. Considering these two different results from a parametric equation, here the size of delta equals a dot. Delta is each point at which it rebounds, the point of inflection. For this parametric equation, the point we're mapping loops back and goes backwards and then forwards, creating a cutoff region. Taken together, these two singularities can ascribe from that single point outward to give a way to calculate something about the interior of the discord, from being a singularity and then expanding outward to describe the interior. It's loosely resonant with just a point, delta equals 0, and a map from that point where the discord is 0 back through all of the other discords until we move from this to this. If it is time reversible, this shrinks down to the singularity and then rebounds in order to form the same picture. Thus, we reach some state delta, we reach the center of that delta, and then we rebound. This is our singularity. It has size 0, so it's delta, comma, size of delta equals 0. Or we could have size of delta equals 0 or r. And in fact, since it has size 0, we call it 0, so that implies that size of delta equals 0 and r, element of r. Very interesting result. I thought this created a problem for me, something being 0 and r at the same time, but it is 0. It is of size 0 and of some size r, where r is the number it represents. And once again we run into its size from 0. Measure of r equals the measure of r, the measure of the distance between r and 0. I think we should assume that delta equals 0 in general for almost any realistic delta, since deltas are inherently unmeasurable, and giving them any size would allow us to take measurements on them. And when we can take measurements on them, we should call them finite delta. But in general, if this relationship holds, if delta equals a singularity, then the size of delta almost certainly equals 0. This would be the continuous version, equals r minus 0. So I should say delta equals a singularity. Delta equals a singularity implies that the size of delta equals a singularity. And since numbers have size, we need to find some way of measuring that, and we do that by taking the difference between r and the singularity. So given this expression holds true, all of these are the same singularity, or it maps from singularity to singularity, starting at the top singularities and going all the way down until we find something we can measure, in this case, and then we pick a point from which to measure it, and that point is a singularity from which we can perform all the necessary distance calculations on the various r. And if we can write those as finite sets, then we can talk about discords that take on a finite number of values, or a finite number of zeros from which we can pick as our origin for the derived conclusions, as in this case. These are the notes for this exploration.